Metals and non-metals. What happens when metals react in water? So metals generally react with water to give metal oxide and hydrogen. This is a generalized reaction and you need to memorize it. Now, the metal oxide formed, if is soluble in water, it will further dissolve to give metal hydroxide. Again, these two reactions are just generalized reactions and you need to memorize them in order to solve the questions you encounter ahead. Okay, so let's perform the small activity to understand how metals react with water. For this, we will take a beaker half filled with cold water and see how many metals react with it. So we are taking cold water and we are actually understanding how metals react with these cold water. Some of the metals will react with cold water, but most of them won't. Now, what next? Out of those who didn't react with cold water, we will try to add them in hot water. Okay, so now some of the metal will react with cold water while some will not. So those which did not react with cold water will be then put in hot water to see if they react with hot water. Again, some will react with hot water and some won't. Those who do not react with hot water, we will see how they react with steam. And by now you might be thinking that why are we doing this? Why cold, why hot and why steam? Like why don't we take a normal tap water and see whether the metal react with it or not? Well, all metals do react with water in some or the other form. However, they won't react in the same way. Some metals will react vigorously in cold water while some do not react in cold water. While those which didn't react in cold water would react much vigorously with hot water. So that's how the nature of the reaction changes according to the metal or according to the metal we consider. Okay, so this is why we are taking it, and by this we can conclude which metal is more reactive and which metal is less reactive. Okay, see, those metals which react with cold water will be most reactive, right? Because it didn't even require temperature for the reaction to happen. However, those who react with hot water will be less reactive than cold water, and those who react with steam, like those who neither react with cold water nor with hot water and will react with steam, will be said as least reactive metals because they didn't react with cold or hot water. So that's how you can actually categorize elements or categorize metals as more reactive and less reactive. Okay, so metals like potassium and sodium react violently with cold water. This reaction is so violent and exothermic that the evolved hydrogen immediately causes fire. Okay, so sodium and potassium both are very much violent and like they react much vigorously with cold water. So you can see how much vigorous it is. It didn't even require any temperature for the reaction to happen. See, cold water already has its temperature quite less, right? And even in that less temperature, potassium and sodium are capable to evolve, like the evolved hydrogen catches fire in cold water. So that's how violent this reaction is. Okay, and here's the reaction of this, the equation of this reaction will be 2K plus 2H2O forming KOH plus H2 plus heat. Again, you have to memorize this reaction as it will be important from the examination point of view. So do memorize this reaction. Okay, what happens is potassium reacts with water to give you potassium hydroxide and heat energy along with evolution of hydrogen gas, and this hydrogen catches fire. Okay, so because of the heat evolved with it. Okay, sodium plus water gives you NaOH, which is sodium hydroxide plus hydrogen plus heat. Okay, so same is the case with sodium, like potassium and sodium reacts vigorously with water. The hydrogen catches fire immediately after the reaction. That's how vigorous the reaction is. So we know that sodium and potassium are very reactive. Like till now, whatever we have studied about sodium and potassium are very much reactive. The reaction with calcium is with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Now see, this is how the trend goes. Potassium and sodium react violently and it catches fire. However, calcium, the reaction of calcium plus water is not so violent, like it is comparatively less violent, and the heat evolved is not sufficient for the hydrogen to catch fire. Now the reaction of the equation of this reaction will be Ca plus H2O forming COH twice plus H2, which is calcium plus water forming calcium hydroxide plus hydrogen gas. Now this hydrogen gas do not catch fire because the energy evolved in this, or the hydrogen or the energy evolved over here in this reaction is not enough for hydrogen to catch fire. Instead, calcium starts floating because of the bubbles of the hydrogen gas formed stick to the surface of the metal. So this is another highlight of this reaction, that calcium starts floating because of the bubbles of hydrogen gas. So you can see the hydrogen gas forms bubbles with it, and these bubbles make the calcium metal to float, and it will stick to the surface of the metal, and thus you can see the calcium metal will be floating. So do you know any other element such? Okay, so magnesium. Now that we have talked about potassium and sodium and calcium as well, let's talk about magnesium now. Does it react with cold water? No, it doesn't. Magnesium do not react with cold water. Instead, it reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Well, you can see that calcium and magnesium reacts in the same way, right? The bubbles formed of hydrogen gas will stick to the surface of the metal, and you can actually see the metal floating in the solution, right? Again, you can see here that magnesium do not react with cold water. However, it does react with hot water to give you magnesium hydroxide. Again, you can see the trend, right? Potassium and sodium react quite violently with cold water, and calcium reacted with cold water, but the reaction wasn't violent enough to get the hydrogen catch fire. However, magnesium, which is again a metal, do not react with cold water, but it does react with hot water to give you magnesium hydroxide. Now the reaction for magnesium hydroxide formation is something like this. Mg, which is magnesium, reacts with water. Over here water is hot water, okay. So magnesium reacts with hot water to give you magnesium hydroxide plus hydrogen. Again, over here you can see these bubbles of hydrogen gas which will stick to the surface of the metal, and thus we can see the metal floating in the solution. So that's how magnesium reacts with water. So till now we discussed about potassium, sodium, calcium and magnesium. Now, metals like aluminium, iron and zinc do not react either with hot or cold water, but they do react with steam to form metal oxide and hydrogen. Again, you can see the change in trend, right? Potassium, sodium, calcium, magnesium at least reacted with water, right? However, metals like aluminium, iron, zinc do not react with either hot water nor with cold water. Instead, they react with steam to form metal oxide and hydrogen. So, the reaction for this is as follows. Al plus H2O forming Al2O3 plus H2, which is aluminium plus water forming aluminium oxide and water and hydrogen gas. Similarly, iron plus water gives you iron oxide plus hydrogen. So over here you can see that metal oxide is formed when these metals react with steam. Okay, by steam we mean H2O in gaseous form, right? It's water in gaseous form. So this is how you see the trend in the change, like the change in trend between the metals and the reaction with water. See, steam itself is also water, right? Steam is nothing but H2O in gaseous state. So now that we have learnt about so many metals, let's move on some of the metals which literally do not react with water. Who are they? Let's see. Metals such as lead, copper, silver and gold do not react with water at all. So now over here you can see this big change in trend, right? C. Potassium and sodium, and C. Copper, silver, gold. Potassium and sodium react violently and give out fire in cold water. However, metals such as gold and silver do not react even with steam. So just leave cold water like far away. So you can see that potassium sodium are quite vigorously react with cold water. Then we have this calcium which do react with cold water, but the reaction isn't that violent enough and it do not give out heat or it do not give out that energy to cause the hydrogen to catch fire. Then we have this magnesium which do not react with cold water but instead react with hot water to give you magnesium hydroxide. Next you see aluminium, iron and zinc metals which do not react with cold or hot water. Instead it reacts with steam, which is again water in gaseous form, right? Steam is nothing but H2O in gaseous form. Lastly, we encounter these metals lead, copper, silver and gold which do not react with water at all. So now that you have seen the change in trends, you can actually predict which metal is more reactive. Yes, you are absolutely right. Potassium and sodium are more reactive, and gold, silver, copper, which do not react with water at all, are least reactive metals, right? So using these experiments, like we have experimented this and we got this conclusion, right? And using this conclusion, we are actually going to build up our reactivity series. See, the final aim to do this is to find out the reactivity series, right? So that's all about the module. I hope you understood it. Keep learning. Thank you.